So today we are starting section 6.6. We're actually going to do 2 days of 6.6. 6.6 is all about just simplifying expressions using all the rules that we've learned. So most of the problems have 2 or 3 rules that you're using to simplify it all the way. So the hard part is first recognizing what you're doing. Are you adding exponents? Are you multiplying exponents? Are you subtracting exponents? And also deciding what order you want to do them in. All right, so that's what we're going to practice over the next couple days. Today is mostly focused on fractions. So we're going to do a lot of simplifying fractions and then raise it to an exponent. So kind of what we did yesterday in 6.5, also combined with what we did last week in 6.4. Okay? Any questions before we get started? So what we're going to look at today when we do these fractions, it's sort of like the order of operations. The fractions will be in parentheses, so we're going to simplify those first if you can. Then we're going to take care of the exponents outside of the parentheses. So today's a lot of work with those fractions, that division rule we used yesterday, and then plus a couple extra steps at the end. You should have all these already written in your notes, so we should be able to jump right into these problems. Now, check out number 1. Does that look familiar to anyone?
No. Yes.
What is this? This is the warm-up, so that's why I didn't collect your warm-ups yet, because I wanted you to be able to look at it. So this is just your warm-up squared. So the first thing we want to do is simplify what's in parentheses if we can. What did we get when we simplified this?
3x over 4y.
Alright, so we're going to get the same thing when we simplify it. But that is being squared. So now we want to go through and take care of this exponent on the outside of the parentheses. So we simplified the parentheses first, just like we did in the warm-up. And then we're going to square that expression. So when we're squaring something, we want to give everything an exponent. The 3 didn't have an exponent, the x didn't have an exponent, neither did the 4. So once you give everything an exponent, multiply all those exponents by this 2. So this is going to be 3 squared x squared over 4 squared y to the 6th. Any questions at the moment? Now, what is 3 squared? 9. Good. What is 4 squared? 16. And then y to the 6th. So let me recap what we did here. We simplified what was in parentheses first, using the division rule for exponents that we discussed yesterday. And by reducing the fraction 6/8. So that gave me this guy. I gave everything in here an exponent. If it didn't have an exponent, I gave it a 1. I multiplied all those exponents by 2. That got rid of the parentheses and the exponent on the outside. So everything was being squared. So I multiplied all those exponents of 1 by 2. I multiplied the exponent of 3 by 2. That gave me this expression. And then I did 3 squared, which gave me the 9. 4 squared, which gave me the 16. What are your questions? So for number 2, again, it's already written in your notes, so we should be able to jump right in. Simplify what's in parentheses first. So here I have x to the 8th over x to the 2nd. What is that going to give me? X to the 6th, and that's in the top, right? Alright, next I'm going to look at my y's. I have y to the 4th over y to the 1st, which gives me what? Y to the 3rd. Is there anything in the bottom of my fraction? No, you could put a 1 down there if you want, But you don't need to. So really the fraction is gone. And I am just left with x to the 6th, y to the 3rd, but that's all still to the 4th. Now I have exponents to exponents. What do I do when I have exponents to exponents? Multiply them. So this is x to the 24th, y to the 12th. Alright, quick recap. I simplified the parentheses first using the exponent rule as I talked about yesterday. When you are dividing exponents and you have the same base, you can actually just subtract the exponents because you have 8x's up here, 2x's down here. 2 of the ones in the bottom are going to cancel out with 2 of the ones in the top. That just leaves you with 6 in the top. That's why we can subtract. Same thing over here. We are left with 3 y's in the top, so y to the 3rd. All still to the 4th power. Multiply the exponents. We end up with this. Questions? Alright, here is the 3rd one. Again, we want to start inside the parentheses. So I have a to the 6th, a to the 2nd. What would that give me? A to the what? A to the 4th in the top. Top, good. Check out your B's. B to the 3rd over B to the 8th. B to the 5th, and where would that guy go? Bottom, so B to the 5th on the bottom. And then that's all still to the what? 4th power. Very good. Now, what do I want to do with that exponent of 4? Multiply by all the other exponents. Everything already has an exponent, so I don't need to give anything a 1. We're good to go there. So I have a to the 16th on the top, b to the 20th on the bottom. If you want to keep it in parentheses, you can, but once you get rid of that exponent on the outside, the parentheses don't really mean anything, so I'm not even going to write them anymore. Questions? Alright, so inside the parentheses is where I always start. It's the first, the P in PEMDAS, the first thing you want to do with the order of operations. So, this is a regular number 9 on top of a regular number 3. What is 9 divided by 3? 3. You could write it as 3 over 1 if you want, since we're working with a fraction, that's fine. Keep it going. We have a to the 4th over a to the 4th. That's the number 1. It's a to the 0, and anything to the 0 power is the number 1. That's a dot, a multiplication dot. Yep. Alright, back here I have the b. B to the 7th over b to the 7th, which is what? The number 1. All to the 3rd power. What is 3 times 1 times 1 divided by 1? What's 3 times 1? Times 1. Divided by 1. 3. It's just 3. Inside the parentheses, all that simplifies down to a 3. Some students need to write out this step. Some students actually need to write down an additional step where they have an a to the 0, b to the 0. That's fine too if you want to replace these ones with a to the 0, b to the 0, and then do an additional step. Or some of the more advanced students will see that a to the 4th over a to the 4th is going to go away. B to the 7th over B to the 7th is going to go away. And you can just cross them out and never deal with them. That's fine too. Either way, you should end up with just a 3 to the 3rd power. You can give it a 1. You end up with 3 to the third. What is 3 to the third? 27. Very good. So again, I mean, a lot of this stuff you don't really need to write out unless it's something you need to see, especially like this step to this step. I mean, whatever you can do in your head, do it. Whatever you need to write it out. It's kind of a personal preference how many steps you show. What are your questions? All right, here's example 5. Again, we have some regular old numbers in the front, some coefficients. What is 16 divided by 2? 8. And that 8 goes in the top. Whole numbers always go in the top. You can put it over a 1 if that helps you realize why it's in the top. But the whole numbers always go to the top. All right, now check out your x's. X to the 8th over x to the 4th. X to the 4th, and that's going to be on the top, right? All right, next check out your y's. We have y to the 3rd over y to the 8th. So that's y to the 5th on the bottom. And all of that is to the 2nd power. Do I need this 1? No, I'm going to get rid of it actually. It's just making more work. I'll have to give it an exponent. I'll have to multiply that exponent by 2, blah, blah, blah. I'm just over it, okay? Give everything an exponent. Give everything that you need an exponent. And then multiply all those exponents by 2. So that gives me 8 to the 2nd, x to the 8th, y to the 10th. What is x to the 8th? Sorry, what is 8 to the... What am I talking about? What is 8 to the 2nd? Too many 8s up there. What's 8 to the 2nd? No. 64. It's 8 times 8. X to the 8th stays the same. Y to the 10th stays the same. What questions do you have? Alright, here's example 6. So normally we start by simplifying what's in parentheses. Can you simplify 1 over y to the 8th? No. So what's the next thing I want to do? Give everything an exponent. Multiply each exponent by what? 5. And that's every exponent, top or bottom. So this is going to give me 1 to the 5th over y to the 40th. No one's allowed to say the number 5 until further notice, okay? What is 1 to the 5th? What did I just say? Nobody's allowed to say 5. Let's try it again. Nobody's allowed to say 5, okay? What's 1 to the 5th? What? It's 1. I don't know why everyone says 5. Okay, 1 times 5 is 5. 1 to the 5th is 1 times 1 times 1 times 1 times 1. No 5s, just 1s. Being multiplied together gives you a 1, okay? Really 1 to the any power is just 1, okay? So again, 5 is now back in play, okay? You can say 5 again. But this is not 5, okay? It's 1. Any questions? Questions? All right, here's number 7. So this is getting into some review. Today's a lot of review, actually. What am I going to do here? Combine like terms. Very good. So x to the fifths go with x to the fifth. So what's 1x to the fifth plus 4x to the fifth? 5x to the fifth. Great. X to the first goes with x to the first. So what is negative 1x plus 5x?
4x.
So plus 4x. Very good. What are your questions? That's it. What else? We good? All right, number 8. Again, this is just review. This is like a negative 1x times 1x to the fifth times 3x to the first. Let's add all those invisible ones. All right, regular old numbers in the front are being multiplied. What's negative 1 times 1?
-1.
And what's negative 1 times 3?
-3.
So I have a negative 3 as my regular old number in the front. Here I have x to the first times x to the fifth times x to the fifth. Or sorry, to the first. Too many f's. Alright, so x to the first, x to the fifth, x to the first. I have 1x here, 5 of them here, 1 of them here, all being multiplied. That gives me x to the 7. You add those exponents. Good. 1 plus 5 plus 1 is 7. So the coefficients, the regular old numbers in the front, you multiply those. The exponents you add because you have 1 of them here, 5 of them here, 1 of them here, all being multiplied together. That's what an exponent is. X times itself, 7 of them. Questions? All right, here's number 9. What should I do? Huh? What? Yeah, multiply the exponents. This is a real quick problem. X to the 15th, y to the 20th. Questions? All right, and last problem of the day. Any ideas where we should start? No. You can start with the 30 and the 20 if you'd like, but you're not dividing them because they're not regular size normal numbers in the front. They're exponents. So what are you going to do with them? Subtract them. So that would give you what? X to the 10th. Good. What about the y's? Subtract the exponents, so you get y to the 15th. Where would that go? Bottom. Okay, the z's. Z to the 10th, z to the 1st, z to the 9th. That'll be on the top. And that's all to the, 0 power. What's anything to the 0 power? No. What's anything to the 0 power? Your answer here is just the number 1. We didn't even need to do this step. But hey, I'm not going to deny you extra practice, all right? So, this step is not necessary at all because anything at all that I put in here to the 0 power is what? 1. Not that variable to the first. This is an x to the 1. It's 1. Not 1x, not 1z, not 1y. 1. The number 1. What are your questions?